Let's go to page 99. Let's go to equation 3.1. Equation 3.1, you have the equation ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. This is an equation for the second degree equation, and this is called a conic section or a conic. Conic means a cone. So this equation represents different shapes of the graph that you will get when you cut across the cone. So right now you have double cone. So if you cut slanted like that, you're going to get an ellipse. If you move up a little bit more to miss the side of you, end with the top like that, you get a parabola. If you cut straight up and down, you get hyperbola. Now there are also other shapes. For example, if you cut straight across, instead of slanted, you cut straight across, you end up with a circle. Now there are also other graphs. It's called a Degenerative Conics. That is if you cut right on this point over here, if you cut across right over here, you get a point. If you cut along here, you get a line. If you cut straight down, up and down, like right over here, you get two lines. So those are degenerate conics. So today what we're going to do is we're going to focus on the parabola. So first conics we're going to focus on will be the parabola. Now if you look at the definition on the bottom of the page 100, so on page 100, definition 3.1, it says a parabola is a set of all points that are equidistant from the focus and the directrix. So parabola is all the points that equal distance to a point and a line. Okay? So if you go to page 101, and if you look at the figure 3.2, so you have a line. So this line is called a directrix, and you have a point. It's called the focus. So parabola is all the points that equal distance between the line and the point. For example, you will have one point over here. Now this spatial point is called a vertex. It's exactly halfway in between. Okay. And if you draw the line across, this is called the axis. Okay. And another obvious point would be right over here, right? So you can see the equal distance, right? And so you're going to have the shape looks like this. And again, another obvious point would be right over here. So again, all the points are equal distance to the point and the line. Now let's go over more characteristics of the parabola. So if you go to figure 3.4, so if you go to page 102, figure 3.4, there are certain specifics. So like this over here, this distance over here, this is A right over here, and this is the A. And if you notice that this is 2A over here, and this is the 2A. So basically you end up with the two squares. So over here, so this is the 2A, this is a 2A, so that's a square over here. That's a 2A, this is 2A, so that's another square over here. And this over here, this 4A is also the coefficient of the of your equation. So if you so let's go to example. Let's go to example 1 and work it through. Example 1 says write the equation of parabola with vertex. Again, write down all your information. So vertex is the origin, and the focus is at 0, 4. And you want to graph the parabola. Again, when you're doing this kind of problem, it's best to go and sketch things out. It helps you to visualize. So vertex is at 0, 0, and this is 0, 4. Again, label all your information. So by looking at these, you can see that the graph is always loop around the f. So you see the graph is going to go like this. So this open to the positive y direction. So it's open to the positive y direction. That means your equation is going to look something. So your form is going to look something like this. Okay. So the direction. This is the direction here, so this facing the positive y direction, so y goes over here. Now, if y goes over here, means x will go over here. And next is your vertex. That's your h and k. So that goes in here. So be minus 0, minus 0. And this number over here is 4a. Okay, the 4a. So over here you can see from here, this is your a right over here. So a equal to 4. So this is going to be 4a, so this would be 16. So again, your form is going to be x minus h squared equal to 4a y minus k. This is in the y direction. Now you also can have it in x direction, which will give you y minus k squared equal to 4a times x minus h. So this will be in y direction, so it can be positive or it can be negative. This one is in the x direction, so it can face to the left or it can face to the right. So it's very important you get direction, then you get a vertex, and you get an opening. Okay? So if you simplify this equation, you get x squared equal to 16y. Now this number 16 is the opening of the parabola at the f. So 16 is the opening. So it means you go 8 on this side, and you go 8 on this side. And so your graph is going to look something like this. So the opening would be 16. Okay, again, the 16 over here. So this tells you the direction. So this is opening a positive y direction. And this number tells you the opening at the f. So 16, so you get 8 over here, 8 over here. Okay? And so that's your equation for example 1. Okay, let's go to example 2. Example 2, it says a parabola has a vertex at the origin. So vertex has origin, so it's 0, 0. And its axis, so if you want to go back to this one, if you want to do the directrix, see the a is 4. So the directrix would be 1, 2, 3, 4, would be on the other side. So the directrix would be y equal to negative 4. So that's the directrix. And the axis it goes through here. So this is the axis of symmetry. So in this case, A is x equal to 0. Okay, so again, directrix is over here. So directrix is the one that all the points are equal distance to the focus and the directrix. Okay. And you can look at this point, for example, this is 8, this is 8, right? This is 8, this is 8. And axis is the axis of symmetry. It goes through the focus and the vertex. And so in this case, x equal to 0. Okay. Okay, so let's go to example 2. So it's a parabola has its vertex at the origin and axis along the x-axis. So that means y equal to 0. Okay, again, you have to understand what I try to tell you. And it passes through the point. So it goes through the point. So the parabola passes through the point at negative 3, 6. And find the equation. So again, you want to sketch all these things out. So vertex is 0, 0. You can label all your information. So vertex is 0, 0. And the axis is y equal to 0. So if this is the axis, okay, that means the graph is going to go this way or this way. Okay, so it's one of these, and it goes through the point negative 3, 6. So you go 1, 2, so negative 3. And it goes through this point. So if it goes through this point and the vertex is over here, so the graph is going to go this way. And remember, this is the axis of symmetry. This is symmetrical. That means if it goes through -3, 6, it will go through -3, -6 also, because the graph is always symmetrical. So that's your graph. So now you're going to start to write your equation. Again, you start with, so since this is going the negative, this is going to negative x direction, so your equation will look, again, start your form. So this is going in the negative x direction, so you're going to get negative x. Okay, so negative x direction. So if x goes over here, y goes over here. And the vertex is your h and k. So it's 0, 0, so it'd be -0, -0. And this would be the 4a. Okay. So you simplify things a little bit, so you got y squared equal to -4ax. So now to find a, you need to go and use the point, substitute the point here to find a. And to avoid losing track of what you're doing, go off to the side. So you got 6 squared equal to -4a times -3. So you got 36 equal to 12a divided by 12 divided by 12. So a equal to 3. So once you find a equal to 3, you put it over here, put it back in here. And so y squared equal to -12x. Okay, and that's your equation. And normally when you graph, you want to get all the essential points, essential parts. So a equal to 3, that means the distance, right? But since you're going this way, so you go 1, 2, 3, so that would be your focus. And the focus would be -3, 0. Okay. And you can notice this is your opening, right? So notice the opening is 12. Again, the negative just shows the direction is negative. The number 12 tells you the opening. So notice there's 6 over here, 6 over here. So give you the opening of 12, right? See that? Okay. Okay, let's go to example 3. Okay, example 3, it says the equation of the parabola is x squared equal to -6y. It says find the coordinate of the focus, so you're looking for the focus. Equation of the direct, so you're looking for the focus, the directrix, and the length of the lattice rectangle. So you're looking for the length, okay, length of the RT. So LT, lattice rectangle. So again, we're going to cover this a little bit more as we go through. Okay. So let's go and sketch these things out. So first thing you want to do is look at the direction. So -y, so the graph is going to go this way. So determine your graph, the direction, and then you get your vertex. Vertex is going to be at 0, 0. So get all the information. Okay, so the vertex is going to be over here. So vertex is 0, 0. And it's going to go down this way. Now over here you can see that the 4a, this is your 4a. So 4a equal to -6. So divide by 4, divide by 4. So a equal to -3/2. Okay, so you go down. So it's -1.5. So you go down, right? So again, this is in the y direction. So you have to go in the y direction. So go down over here. So that would be the f. So f, again, by looking at this, you're going to be 0, -3/2. Okay. So that means graph is going down this way. Now, this number 6 is the opening at the f. Okay, so 6 means you go 3 this way, 3 the other way, right? So you go 1, 2, 3. And you go 3 this way. Oh. Now this is off. This one should be right over here. Okay, so your graph is going to go like this. Okay, so again, let's go back. So make sure you answer all parts. Okay, so the focus, okay, we got that, right? So the focus is 0, -3/2. So we got that. Directrix. Directrix is the opposite of the F. So if F is going down, the directrix is going up by the same amount. Okay, so here should be, this would be your directrix. So directrix would be y equal to 3 over 2. Okay, it would go opposite direction. And it does not ask you for it, but if you're looking for axes, right? Here's an axis. So axis would be x equal to 0. Okay, so this would be the A. Okay, and this would be the D. Now let's go to the lattice rectum. Okay, lattice means the word lateral. Okay, so lattice rectum. Lattice means lateral, means sideways. That's where you get the word lateral from. That means going to sideways. Rectum means straight. Okay, so again, rectum means something that's straight. So lattice rectum means you go straight sideways. So that means it refers to this. So this is the length right over here. And in this case, the length is equal to 6. And that's the number over here. See this number over here? That's that. Again, remember, this number is the 4A. It's also the opening at the F, right? Opening F. And that's the lattice rectum. That's the length of that. Okay? And you can just use the L, stand for lattice rectum length.